Hello, everybody. Welcome to the fourth Quantum Computing Weekly Recap. This week we have insane news from Google announcing their Willow QPU. I'll get into that immediately. We have new Qubit technologies coming out of MIT and other researchers. And we have some funding and also some new startup technology collaborations. So let's jump into the Willow. Willow is an insane announcement by Google where they actually managed to hit error correcting qubits. And this is a massive accomplishment because the period that we've been at now is noisy qubits that were too error prone and too few of them to create a larger qubit that is a bunch of little physical qubits all creating some single error corrected qubit. And Google managed to actually create quite a few of these. They have a 105 qubit chip, and on that chip they were able to create 3x3, 5x5, and 7x7 grids of qubits to do error correction. And it worked. As they increased the error rates from 3 to 5 to, from like 9 to 25 to 49, they were able to show a decrease in error. They have a bunch of videos on it. There's a lot of news coverage. So definitely recommend checking this out. It is a huge step forward. The actual benchmark that they created and then benchmark their system is a little bit debated. So I wouldn't take these numbers that seriously. Though what I would say is the biggest kind of takeaway from this research and from this announcement was having error correcting qubits a huge accomplishment. So this is a massive step forward for the entire field. Very incredible news. So I wanted to start off the recap by talking about that. Now we have a very exciting article from MIT, some research they announced where they're actually using these things called fractionalized electrons. What I think it kind of means is that the spin of the electron isn't exactly up or down. So if you have a magnet or if you have a compass, right, that compass will align itself to north, wherever that is. And that would be kind of like the electron spin. It's like a little magnet that'll face a certain direction. But obviously electrons are so small that they exhibit quantum properties. And what the researchers at MIT were able to do was create these kinds of electrons that didn't only face up or down. They could face like a quarter of the way up, or in the opposite direction, a quarter of the way down. And using that, you could then point that electron in any direction to encode information, and then you could have them entangle with each other, and you have qubits out of electrons using these different spins. So new qubit technology is always amazing. You get an entire new startup or companies out of this technology, like Google and IBM with superconducting qubits. Maybe we'll see some companies come out with these non-abelian anyons, whatever that is. It's just electrons between two very, very thin materials. So that is exciting news out of MIT. We also have a new state of matter, which doesn't happen very often. It's called a quantum spin liquid. And this is somewhat similar in my reading to the MIT research. But the idea was you could take a specific kind of material. The idea is you could cool it down a lot, and then you can get these little particles that are sloshing around that material in such a way that's actually quantum mechanical. You can observe quantum mechanical properties, like it says here, that behave a little oddly. The states are interconnected. The states can even exchange information through quanta of light. So little light emissions from them can transmit information. So those are all of the building blocks you need to have a working quantum computer. It might even be as simple as taking some of this material, cooling it down to near 0 Kelvin, and if you can control it well enough, you have, spin, and you have communication between the qubits. So this could be an entire way of creating a bunch of qubits, billions of qubits maybe. I don't know. But extremely awesome news. I mean, 2 different breakthroughs in qubit technology in 1 week is outstanding. So amazing job to these two groups. It's really exciting. And now for some application news. CUDA-Quantum actually worked with Infleqtion to create a quantum computing demo with logical qubits. This week is so amazing because we have moved from the NISQ era into sort of an intermediate era between NISQ and actual utility. And we're seeing these companies now, Quora, Google, Infleqtion, they are all moving toward logical qubits. It is so exciting to see finally these quantum computers are reaching the second stage of their development. And cuda-q, an amazing platform. It's cool to see all this GPU technology that is so advanced, so fast, working with the quantum computers that, have to pick up the speed a little bit in the next coming years. But if you can have a very nice hybrid approach where a GPU takes care of classical computing tasks, even a CPU in the mix, and then you have the quantum computer taking care of, optimization or whatever it does best, especially with a logical qubit that actually can sustain its quantum state a lot longer than just a physical qubit. Well, what I mean is physical qubits can create one logical qubit. So with Google's example, they use 9, 25, or 49 physical qubits on that chip to create one logical qubit. So this is really an incredible achievement. We have 2 logical qubit announcements in 1 week. And NVIDIA's CUDA quantum platform is really fantastic, super fast. It's a great SDK. Very great news coming out of NVIDIA and Infleqtion for their logical qubits. Now we have some interesting news coming out from IBM in the state of Illinois. Illinois wants to create Chicago as this quantum hub. And we've seen this idea of a quantum hub after obviously the success of Silicon Valley for classical computing, and not really so much outside of Silicon Valley. Chicago wants to become the quantum hub, as does Bothell, Washington, and Quantum Basel in Switzerland. So these different groups of people are wanting to establish themselves as the big quantum hub, which I would expect means more funding for different startups in those areas, which is great to see. But IBM is actually installing their Quantum System 2, which is, if you've seen IBM Heron or their latest chip of QPUs with 156 qubits now. They're installing that computer, which is going to drive a lot of algorithm improvement. It'll definitely push the university forward. UChicago will be able to use that system and presumably other universities in Chicago area. So very exciting news. That computer is one of the best computers that you could even use, and you could use it actually for free if you make an IBM Quantum account. So this is awesome to see. It's really cool that Chicago is supporting IBM and getting quantum computers to developers and users, and hopefully more startups in that area that use the technology. Along this trend of moving from the NISQ era, where all the qubits are pretty bad and error prone, toward utility, Quobly is working with STMicroelectronics to actually create manufacturing pipelines for millions of qubits. And that is a crazy statement to make, but it's where we need to actually be. Initially, what they're going to do is create a 100 qubit machine using STMicroelectronics' own fabrication strategies and fabrication plans. And if Quobly can create a 100 qubit machine, then it shows that, hey, like, our theory works on your fabrication. Now let's try to bump it up to 100K qubits and beyond. And notice how they say physical qubits here. This is cool because it's implying that these 100K physical qubits are going to be split up into logical qubits. So I mean, if we took what Google did with their 7x7, that would be a 2,000 qubit system, which is just an immense number. And this isn't physical qubits. This would be logical qubits, way more long-lasting, high-fidelity qubits. So I'm very excited to see if Quobly can actually create a 2,000 logical qubit machine in the next couple years. That'll be fantastic. And it actually brings me well into D-Wave getting $175 million equity offerings. So they recently announced their 5,000 qubit machine. and this is their quantum annealing superconducting qubits. So they do one specific task, but they do it very well. This is 5,000 qubits, so it's even more than 2,000 qubits. But these 5,000 qubits only do optimization and annealing and minimizing energy of different problems, which is a big usage right now in quantum computing. But if we have something like Quobly creating 2,000 logical qubits, I mean, that's just like an insane amount of processing power we'll have on our hands. But let me get back to D-Wave. I think it's really exciting to see different qubit technologies. We will need quantum annealers for different problems. And I would imagine in the future that if you needed to run a Shor's or a Grover's algorithm, you're going to be running it on, Queras, neutral atoms, ion Qs, ions, like whatever different technology, qubit technology that can do general purpose computation, that'll be run on those chips. If you need to do an optimization problem, well, now you have D-Wave's massive, 5,000 qubit machine, or in the future, hundreds of thousands. And I want to wrap it back too by saying, we are reaching a point with error correction on these qubits, new types of qubit technologies, entire workflows around this hybrid process of quantum computers. And governments are getting into funding all of these computers, and these different companies are working together to create pipelines for manufacturing and creating these large computers. I really think this week is one of the most important weeks in quantum computing breakthroughs ever. I think this week is going to be looked at in the next decades as like the start of the end of NISQ and the start to approach quantum utility and quantum advantage in the near future. Thank you so much for watching. I am so excited about this week in quantum. I hope you are too. If you are, hit that like, subscribe for more. I'll be posting these each week. And if you didn't like the video, let me know in some comments, ask questions, whatever. I'm happy to answer. I'm happy to improve. Thanks so much, you guys. See you next week.